Hi, everybody. This is John Wolpert, Kyle Thomas, Sam Stokes, and Karthik Solapuram here for the fourth session on the baseline protocol V's version 0.1 release. What you need to know as a developer, as a contributor, as a user, or an extender of the baseline protocol's reference implementation v0.1. Kyle and Karthik will take it away. Sam and I are going to be asking questions. Sam's going to be watching for code that would not be obvious to a normal practitioner. And so, Sam, you're going to watch out for that and ask Kyle and Karthik where you see stuff like that in the inline code. And I'll be asking some architectural questions. So, Kyle, take it away.
All righty. So I think for today's episode, we want to talk about a little bit more in depth around the privacy package and how another implementation may present itself beyond just the Socrates service. For example, zk sync or Plonk implementations. zk sync could be useful in the context of the privacy package.
Right.
As an additional provider alongside Socrates to help with scaling.
And Socrates, for those who don't know, is a circuit development tool, right? That allows you to take a business logic or basically code and turn it into addition, subtraction, and multiplication, right? So that you can so that a zero knowledge process can validate the code without it being in the clear. Is that a fair statement? Okay. Mm-hmm. So and Plonk is another alternative, or is it an alternative way of getting the setup?
So it's sort of an alternative mechanism to doing setup. It's more of like a setup once. It's more generic, where like Socrates circuits are very specific to the use case potentially. So the circuits and the setups that we would run in like a zk sync context would be more useful in a generic sense of the word, meaning a single setup could be used for like we might have a setup for example the Radish 34 use case.
Radish 34 being the original demo that we produced.
And that's probably a little too specific. Even it's probably a little too specific.
Right. So in the Radish 34, for people that don't know, there's a specialized circuit, right? That specifically governs the relationship of purchase orders to a discount rate table. Makes sure that the rate table is correctly formed, and that updates to the rate, like as you order new stuff, the state of the total amount of orders goes up, right, and nullifies the previous proof on the mainnet, more or less. Okay.
Yeah. So so we're looking at for example the proxy contract within the zk sync context. One thing that we have been looking at is turning this proxy contract into the workgroup proxy contract that has is essentially a proxy to verifier contracts per identifier, and so essentially a little bit of refactoring would be required to modify, like for example, the upgradability of each verifier, where each verifier is a target, and instead of calling set target, we would add an additional parameter here to correspond with the identifier generated by the privacy package. And similarly, upgrade target, we would be, similarly passing in call data for, that included the identifier as generated by the privacy package. And then there's this default fallback function that does the actual delegate call into into the appropriate verifier, given given that the call data is compliant with the baseline protocol message that we discussed before, and having that not only the shield contract, which is you can sort of think of this proxy as sort of the shield address, and then the identifier to correspond with the workflow would be provided with a call to that. So Karthik, do you want to add anything here?
Yeah, yeah, definitely. I think this was a good coverage of what you provided, Kyle. I'll take a step back and provide some context around how verification comes into picture, or where verification plays its significance. And in doing so, I'll try to answer even Sam's question that he posted on the chat. So essentially, what we're trying to do over here in this process is with the so there is two aspects of this that's in play. One aspect is the capability or the functionality to generate a proof, where proof is any truth about a business statement or a business process. For example, when we're talking in the case of supply chain, as it was implemented in Radish, one of such business documents, which marks the start of the process, is, say, creating an agreement or creating a master service agreement. So the truths or the proofs around the master service agreement creation would be, for example, checking whether or not that master service agreement is being signed by two parties, minimalistically, and so on. Now, that is one way. Now, that is a proof that is generated. Now, as you tag along more proofs, say, for example, there are subsequent processes following MSA in the case of supply chain, for example, purchase order or invoicing and so on. Then you might need to attach more proofs that are contextual to that particular business process. Just like how MSA may have a certain business proof or business validation, similarly, a purchase order may have a second order, so to speak, validation, wherein it depends on the fact that MSA has been proved and verified. And then subsequently, purchase order that is being created, for example, is linked to that particular previous proof. That is one sort of like fundamental basis of traceability that you want to establish between one process going to the next. Now, coming back one step from there, why we are talking about these proofs is that we want to be able to use some technology or some class of technologies, like say in privacy technologies or cryptographic technologies, which essentially help in establishing these proofs, or essentially generating such proofs which can be verified without revealing the contents of what went into that proof generation. So for example, if I want to create an MSA and I don't want to reveal that contents to, and I want to create an MSA to and publish that MSA to, say, for example, John, and even though, say, Kyle and Sam are also in that, say, groups, I do not want Kyle or Sam to know what agreement terms I'm agreeing on with John. Now, how do we establish that on the mainnet? That's where I think this class of privacy technologies called zero-knowledge proofs help. Obviously, there are many other encryption methods and technologies, and why ZKP plays a prominent role over here is that it provides a way to not just encrypt data, but also quote unquote encrypt logic. So whenever there is a business logic or a business rule associated with a particular data element, and that particular logic also needs to be proved, or a proof that needs to be generated based on that particular business rule, then that's where I think the strength of this class of privacy technologies called ZKPs come into picture. Now, as Kyle was covering, the Socrates is one such tooling or library, so to speak, which leverages a particular type of ZKP called ZK snarks to essentially run this mechanics of generating proofs. Now, that's the first aspect of the proof generation, and that's all of this is done offline / off-chain. Now, Socrates is one such provider, and the way Kyle has been structuring this or has been explaining this is that there can be different types of such providers for different types of ZKP libraries or services or technologies out there. Just like how Socrates is one type, the part that around ZK Sync and Plonk that Kyle was covering earlier have some other variations in how the ZKP proofs ZK proofs are generated.
So
Now,
Karthik, that would, to net, that would be that we're future proofing if one particular zero knowledge circuit provider or system or protocol were to no longer be, the future. The fact that we've abstracted this will allow you to just keep up with the times, correct?
Yes, the idea is that we abstract these components as much as possible so that one, we do not tie ourselves to a particular tooling or a particular type of, say, ZKP even. Like, not tying ourselves to just ZK snarks, but also to provide a way for the community to say that it's not just tied to one type of ZKP solution. You can keep adding other types of ZKP solutions too. Now, that's where Sam's question comes into picture. In what scenario would you use Socrates versus, say, Plonk or anything else? Now, I think it's a very good question in the sense that how do you define a class of problems that would be solved by a specific type of a ZKP technique? A crude example could be ZK snarks, like and tooling that enables usage of ZK snarks, things like Socrates and Snark.js. They allow you to run this proof generation for, say, any proof circuits, like, for example, any business logic generally. So they are very efficient to take any sort of arithmetic computation or a logical computation and create a proof around that. These specific technologies or this specific class of technologies, crudely speaking, they are efficient at doing so. But now there are some other technologies out there like bullet proofs and so on, where they focus on a different type of a problem, where the focus is on constraint checks or range proof checks and so on. So to the extent that a particular sort of a business problem requires a certain sort of privacy tooling, is where I think is our primary aim to make sure that this is extensible so that different proofs can be added. And finally, that's where the whole aspect of verification comes into picture. Given these different types of proof generating methods, how to have a unique way of verifying them, or not say unique way, let's just say a common gateway of verifying them, depending on which circuit type, which technology type, and which type of proof that you're choosing. And that's where I would say the whole aspect of, say, leveraging or looking or getting taking inspiration from some of the practices that are being used by ZK Sync and Plonk are coming into picture. How do we combine all these types of proof generation techniques to still be able to have multiple types of verifications, and if needed, coalescing these multiple types of verifications as and where necessary. Now, that's a larger goal, but at least from an abstraction point of view, we want to be able to provide different types of ZKP providers that will be and that will be integrated with the overall work group itself, where there is a common way to verify any such form of, say, privacy-enabled, business validations.
So I see while you were talking, Karthik, and thanks for that. I mean, that was, it's good that we're getting this on video because I'm going to need to go back through what you just said about 3 times, and I'll grok it from there. That's pretty deep stuff. I think, it's kind of instructive that we're watching Kyle actually put together some of the code right there in front of us. Now, Sam, I think you had a couple of questions, right?
Yeah, I think Karthik and Kyle typing here is kind of addressing what I was asking.
Yeah.
Karthik already alluded to it. Yeah, one of the questions was, do you envision a scenario where somebody might want to use a combination of ZK circuits? So you could, where you could potentially have like a Socrates generated circuit, which you said might be more geared towards a very specific set of business logic, combined with another ZKP that's, I guess, better geared towards being generalized. Is that something you see happening in the near future, or would you expect the user to more choose one or the other at kind of the initial setup phase?
So I can take a stab at that. I mean, Karthik, I'd love to hear your thoughts too.
Yeah,
my thought is, you know, initially it'll be very much you'll pick your poison.
Yeah, I was just saying that, like, as Kyle was pointing out, like, you know, it's pretty much pick a circuit for a type of a problem. So it sort of becomes a little bit of a solution, rather the issue, not issue, sorry. It's more around the solution of which, like, or design of which sort of circuit you want to choose for a certain type of process. But that being said, like, I think there is also the consideration in the upcoming, like, few months or even probably over a year, where we project that there could be a way where you can have any number of proofs that can be generated subsequently, but you don't need to run multiple verifications for each type of proof, but you can roll them up into one verification, so that even if you have a composition of multiple proofs, that could work. But then that would mean that all of them have to be homogeneous. Then we cannot switch between, like, you know, ZK circuit here and a Planck circuit there or something like that, unless there is an initiative, something like we come up in baseline maybe to, like, have some sort of a proof composition method which will work.
Right, and Karthik, that would if I understand it correctly, would reduce the gas costs and increase the amount of workflow steps that can be handled in any given time frame. On in particular, if people are using the actual mainnet as their common frame of reference, right?
We have some ideas. We have some ideas to reduce gas costs, just even in the sort of unoptimized approach.
Oh, sure, but you know, given that this is just about making sure people understand what the landscape is for v0.1, let's stick with that. Actually, I'm going to break that rule right now by asking a couple of questions about the implications of the current code. First of all, I think right now the generalized circuit that we already went through in a previous session is a Kyle, I think we went through that in session 1 or 2. That is two-party right now, correct? It's you wouldn't be able to do a synchronization between records in three or more parties currently, right? That's still work to be done, correct? So two questions. One is, if I wanted to build a brand new circuit, right, for some specific business process, maybe I'm a regulator, maybe I'm a auditor. Karthik would know some things about that at EY. You know, if I'm trying to be sure that there's correctness in a particular piece of business logic, and I want to make the effort of adding a specialized circuit, not just use the generic consistency check circuit. Where would I go? What would I do? And you might take, for example, just how would you modify the current work to create something that works for 3 or more parties? I'm not asking you to write that code right now, but I think it'll be instructive for people to see where they might go to contribute in them.
So the question is, how would we think that, or rather, if right now we're talking about a two-party situation, if there are multiple parties interacting in, say, the creation of an agreement, or say the approval of a certain process, or anything to that extent, when multiple parties' inputs need to be taken in.
Yeah, or for example, in the current generic one, right? It's just then the consistency, right? So, but right now it's only 2 parties.
In the create agreement circuit, how do we modify it to be multi-party? And I'm just going to hack around on the code while Karthik talks about it.
Okay, so it's actually a very good question in general as to how would we solve, like, a multi-party signature under the context of a zero-knowledge proof. I think one way to do it would be, like, somewhat more at a proof level, in the sense that we a proof level as in at the circuit level, where we add in, like, multiple party signatures, like, as a part of the inputs to the document. But that's basically, that doesn't it solves for a problem where the number of parties are sort of finite. But the thing is that as the number of parties grows and it's indeterminate, then maintaining such a circuit or having like a general circuit or general business logic that would work for any and such parties it's definitely a difficult problem at this point.
Lib circuits is where the circuit library lives. I think we would probably want to look into, as far as the actual solution, something around multi-party computation in terms of one of the public inputs to a circuit, and then it gets pretty complicated. I would say beyond that.
That's
but I think
awesome.
a multi-party computation could be probably part of the proof generation process, to enable some form of that, maybe like with ring signatures or something around that.
Yeah, it turns out 80% of business processes are bilateral, but there are some notable cases where they are multilateral, where at least the consistency needs to be more than two parties, right? So that's definitely, and I know that that's on our roadmap, and it's not like it's weird science to get there. It's just hard work, right? And choices to be made. But I think it's really interesting, and actually, I'm really glad to have this piece of the video to show folks. I mean, I think this is really great what you're doing right now. At least in high def, people should be able to see the where they should be going.
I think Kyle pointed out one of the approaches that has been considered or that has been discussed. I think even Sam is also aware of this, around using ring signatures as one approach to be able to sign a document in such a way that it's a combination of multiple user inputs or like multiple private keys in general. I think that could be like that is definitely a good approach. The whole aspect of how ring signatures would effectively transform into like a circuit that could be defined, that is, I think, still under construction. But in terms of where people could go for or how they could go about this, is one very simple, crude way is to take a create agreement circuit and just add multiple signatures to it and keep verifying the signatures one after the other. It's very crude. It's very not very
it's perfect.
scalable, but
that's how I would do it, by the way.
Yeah,
because I'm terrible, but that would work. Yeah, great.
Yeah, there is a better approach. There are better approaches. Ring signatures are one approach, and it comes along with ring. There is still work to be done in terms of, if you use a ring signature, how do you verify it under zero knowledge that it has been signed by n number of, at least m of n parties, and so on and so forth. There are some open problems out there, and I believe that there is.
Those are the fun problems.
Yeah, and I'm sure that there must be some solutions also. It's a matter of us like collaborating further in this community and reaching out to all the good effort that is going on out there.
Right on. Well, let's stop here on this. This is wonderful. I think this is more than enough for folks to really get their teeth into the work, and I think it gives a good sense of where the layout of things are. So let's move on to just let's wrap this session up.